Hi, first period. I wanted to make a short video going over the back page of your outline, just so that you have some explanation to go along with the posted notes in Canvas. So the back page of your note outline is focused on the composition skill, which was like the second half of our lesson. When you have the notation that looks like this, so this is an open circle right there. And so when you see that, you need to know that that's different from the notation we were doing earlier in the period where it's a closed dot. So if it's a closed dot, that would imply multiplication, where you just multiply the F terms with the G terms. But if it's an open circle, like this, like it looks like the word fog, that actually means something different. That means that we take the G of X expression, whatever that is, and it gets plugged into the F expression. So it means F with G of X plugged in place of X. Yeah, okay. So, and then function composition is not commutative, because you'll get a different thing, or you may get a different thing if you do F plugged into G versus G plugged into F. So let's look at the back page of your note guide. We're going to follow those rules of composition. And in example 2A, it starts off with wanting us to try to find what F of G of X is. So that's how you would read this. This is F of G of X. So G of X is this whole entire thing. And if I need to find F of G of X, what I do is I take all of the G of X expression, that whole expression, and it goes in place of X in the F of X expression. So you could say that this is equal to F of all of that. And when you have this expression in the parentheses, that means this takes the place of X in the F of X function. So then this would equal X squared minus 2X plus 7. That goes in place of X, and then we just put plus 5. And so the only thing I can really do to simplify would be to add the like terms of 7 and 5. So F of G of X in this case ends up being X squared minus 2X plus 12. So in part B, it wanted us to take a look at what happens when we reverse the order. So by the way, this notation, this open circle right here, that means that we're going to take all of F of X and actually plug it into G. So it doesn't mean G of X times F of X. It means G of F of X. So this would be G of F of X. And the order does matter. So now what's happening here is F of X is plugged into the G function. So this is going to go the other way around from what I did last time. I'm going to take the entire F of X expression, and that is going to get plugged into the G of X function everywhere that G of X has an X. So I can think of this as G of X plus 5, because that's what F of X is. It's X plus 5. And G of X plus 5 means, so G of X plus 5 means that you take this X plus 5 and that goes in place of wherever X is in the equation for G of X. So in this case, it's going to end up being X plus 5 squared minus 2 times X plus 5 and then plus 7. So it's the G function rule applied to X plus 5. I square it first, I multiply it to -2 second, and then I add 7. And then as a reminder, when you're squaring a binomial, you have to FOIL it. You have to write it times itself and then FOIL that out. Here, it's just multiplying one term to two terms, so I just have to distribute there. Don't forget to distribute the negative as well. And then the last part is just adding 7. So this part I will need to FOIL. So this part gives me 4 terms, and then I have to subtract those last 3 terms, or subtract these, add that one. So when all is said and done, I have x squared, and then I had 1, 2, 3 like terms that had an x. So 5 plus 5 minus 2 added to 8. And then I have 3 terms that are just whole numbers that I can add together. So 25 minus 10 is 15. 15 plus 7 would be 22. So g of f of x, this thing right here, equals this, x squared plus 8x plus 22. And you can see that it gives you a different answer. So if you do g into f, you get x squared minus 2x plus 12, which is different than if you do f into g, which gave us x squared plus 8x plus 22. So this is just another reminder that composition is not commutative. The order matters. And so you have to be careful with the order. So it's whatever's inside stays like the same and gets plugged into the one that's on the outside. So the one that's on the outside is the one whose x gets replaced with something else. So it's this, the function on the inside gets plugged into the one on the outside. Or you could think of it as the function on the right, that one gets plugged into the function on the left. So the order matters. Okay, so now with this one, again, it's got that open circle. So that means we're going to compose those 2 functions, not multiply. And in this case, I'm composing f with itself. So I take f of x and plug it into its own expression. So this would equal f of x plus 5, because that's what f of x is. It equals x plus 5. So I'm going to take itself, and then that gets plugged into the x value for itself, because I'm composing with a function with itself. So then it becomes x plus 5 in place of x, and then plus 5. So it's like f of x plus 5. And then that just becomes x plus 10. So this is also called an iteration. An iteration is when you like take something and plug it into itself, and you can do that over and over and over again. And anyways, it's just like another fascinating branch of mathematics. Okay, then the last one over here, I wanted to just kind of show you this as a reminder of the difference between an open dot, like these were open dots, versus a closed dot. So when you have an open dot in your notation, that means you're going to take the function on the right and plug it into the function on the left. But if you have a closed dot, that means you're just going to multiply the 2 functions together. So that goes back to kind of old school or more simple arithmetic, just multiplying each term with itself. So it just would be x plus 5. I'm not plugging that into anything. I'm just multiplying it to all of these other terms. And so again, I'm going to have to distribute multiple times. And you can do that however you prefer. I like to organize my work in a box, but that is not the only way to do this. It just helps me keep all the terms organized. So I usually have the shorter one on the left, and then I can have the longer one go as far as I need it to. So I'm going to do the 2 terms over here, the 3 terms up here. And then each box is just the product, so it helps me keep track of making sure each term gets multiplied to each term. Okay, so then once I get all my terms, I just kind of notice the ones that are like terms, the ones that have the same exponent. So I have a negative 2x squared and a 5x squared. And then I have a 7x and a negative 10x, and I can add all of that up. So I end up with x to the 3rd from here, plus 3x squared from these 2 added together, and then minus 3x from those two added together, and then plus 35. So again, in D, I was multiplying, not composing. To compose two functions, you would have to see like an open circle like this, and you would have to literally take one function and plug it into another. Okay, so then the last example on the second page of your notes is when we evaluate. And this time we're evaluating a composition of functions. So I have two different equations here. I've got an h of x equation and a p of x equation. And then I have all these different things that I'm supposed to do with those equations. So I'll start with A, which again, it's got that open dot. And that means I'm going to compose two functions together. So like p of 4 is going to get plugged into h. But let me show you the order. So I work my way from the inside out. So I start with 4 and plug that into p. So here's p right here. So I'm going to take the x value of 4 and plug it into the p function, which tells me to cube the 4, which is 64, and then to multiply that by 2, which is 128. So p evaluated at 4 results in 128. So then this becomes the y value of p when x is 4. And so that is the thing, this is the thing I'm going to then plug into h. So now I do h of 128. So the h rule says to do 1 divided by x, whatever that is. In this case, it's 128 plus 2. And so I end up with 1 over 130. And so that was the result of composing 4 into p and then that into h. So you work your way from, or you can think of it as going from right to left. 4 into p gave me 128. That gets plugged into h, and then I evaluate h at 128. So in B, it's the same idea. Here it shows us using the function notation. But this time, if I work my way from right to left, 4 actually gets plugged into h first. So this is going to become like p of whatever I get when I plug 4 to h. So h of 4 would be 1 divided by, I plug 4 in for x, 1 divided by 4 plus 2, which is 1 over 6. And then that value is the thing that then gets plugged into p. So just color code this. So I take the answer to what I got when I did h of 4, and then that is what goes into p. So p of 1 over 6 would be when I cube 1 over 6 and then multiply that by 2. So that would be 1 cubed over 6 cubed, and that is 1 over 2, 16, and this is like 2 over 1 times 1 over 2, 16. And so I can reduce, 2 can divide evenly into 2, 16. It would become 108. So p of h of 4 becomes p of h of 4 mean 1 over 6, so p of 1 over 6, which becomes 1 over 108. So again, we can see here, this was when I took 4 into p into h, I got 1 over 130. But if I do 4 into h into p, I get 1 over 108. So we can see order matters. Here h was first, here p was first, and the answers were different. So just a reminder, composition is not commutative. The order matters. Okay, so for the last two, I have C and D. I'm basically, again, switching the order. Here P is first, here H is first. And then I'm taking X as -1 and plugging it into one function, and then the answer to that into the other function. And you work your way from right to left. So I will start by taking the -1 and plugging that into H, because you go from right to left, or inside out. -1 is inside, and then I work my way out from there. Okay, h of -1 becomes 1 divided by, I plug the -1 in the x spot for h, and then I add 2 to it. So 1 over 1, which is 1. So h of -1 actually equals +1. So then I take that answer, right, this answer, which equaled 1, and plug that into p. So that went in there. And then I follow the rule for the p function, which is to take 2 and multiply that to the x cubed. So 1 cubed is just 1, and then 2 times 1 is 2. So p of h of -1 is equal to 2, because that's what I get after I took -1, plugged it into h, so -1 went here and resulted in that. And then I took the answer to that, plugged that into p, which resulted in that. So this is the final value for p of h of -1. Now we're just going to do the same thing, but backwards or in a different order. So I'm going to start with the most inside and work my way out. So -1 goes into p. So that goes in place of the x right there. So it's 2 times -1 cubed. -1 cubed is -1. 2 times that is -2. So when I took -1 and plugged it into p, it resulted in -2. So now I take that answer and plug that into h. And so that would go right here. So I have 1 over -2 plus 2. And so here I'm running into a bit of a problem, right? So this value does not exist. This is an undefined value. Because for the h of x function, which was right here, the 1 over x plus 2, for that function, x can't be 2. Or sorry, can't be -2. And that's just whatever input. Like the input can't be -2. So when I have h of p of -1, when that becomes my input, then that means p of -1 can't be 2. Or whatever is there, like whatever I end up putting in here, that value cannot be -2, because then h of that value is not defined. But in this case, p of 1, or -1, sorry, was -2. So we have a problem. This can't happen. I can't go that way. H of -2 doesn't exist, so therefore h of p of -1 does not exist either. So we just have to be aware of that. The domain for h of x is now being plugged in by the range of p. So basically the range of p in this particular context can't be -2 if I'm going to plug p into h. And since it was in this case, then this value just doesn't exist. And that's it. So I hope that this was helpful to you. I also have this completed page pasted or like uploaded in Canvas so you can review that as well. Then you have your Delta Math assignment to practice. And so I'm hoping with all of this, you'll be feeling a little bit more comfortable coming into our quiz on Monday. And I will see you there. Bye.